Okay, while we're gathering, I'll talk about a few things in the Oracle world that I've noticed to make people know that something's going on when they check in. So, first thing is that Oracle is going to have some live webinars. They've learned from us, I guess. more likely they've learned from the Finnish guys that held a few of those over the fall and winter, and worked out well in Finland. So now the Swedish Oracle is taking a cue from them. So there will be at least 3. There will be one that talks about the database. Will most likely focus on version 21 that just released, and all the new interesting things in it. There will be one which is a general overview on the cloud services and where it stands today. And it's going to be one about Oracle Enterprise Manager to see what's in it and what's coming and what's next for the monitoring product. And speaking of the new version, I don't know if we're going to talk JSON today, right? So I don't know if everyone has noticed that in version 21, Oracle is introducing a JSON data type similar to the XML type we already have. It is apparently needed to take the JSON functionality where it needs to go to really get to the next level. A formal data type was needed. And as we talk about new things, Oracle just released a new cloud service, Apex Cloud Development. There's a lot of Apex there that is bundled in other things. This is a pure Apex. You just start it and you're in Apex immediately and get going with development, and don't need to bother with all the other things, with having a database and all of those things. For pure developers, this is supposed to be a really good thing. I imagine that database-centric people will still want to have a service that is database-focused to get the most out of the database. Because with Apex, you get only the Apex interface, and there's no database you can connect to. So it's out there. I just saw something that it's part of the free version of it, like Autonomous. I've not heard that before. I thought it was always for cost, but apparently you can now hook up one of those in the free forever cloud thingy. And the last thing before we reach 6 o'clock here is that we would love to see more local speakers. If you're thinking that maybe you would want to do that, please contact us. We will help you. We will hold presentations together with you and get you ready whichever way you want. The more local people we have, the better for the community. And let's see where do we have the time? It's 6 o'clock. And another thing the professionals of this stuff says is that you should never wait. When it's time, you get going, because that is respect for those that has signed in. I agree with that, so that's what we're going to do here. So a little bit about me. My name is Matthias Magnusson. I'm the owner and consultant at Evil Ape. And I'm the founder and the leader of SWEOUG. My blog is orackedb.matthiasmagnusson.com, and you find me on Twitter at MatthiasMag. I'm an Oracle ace. And if there's anything that you don't hear right or something, please write something in the chat. And if someone could just write something there, so see if I see it, that would also be good. I'm gonna change one thing there. All messages. So, speaking about the Oracle ACE program, let's talk a little bit about it. Those that hear me often has heard this many times. But here's the main slide for the Oracle ACE program. There are 3 levels. You tend to start as an ACE associate. That's where you enter the program. And then you become an ACE, and maybe you one day become an ACE director. There's some more information here, and if you want to get involved with the community, if you want to work with sharing information, this is for you, and you may want to work towards being nominated. I can talk to you about how that works, why you may want to do it, and what it takes to reach the level where you can enter the program. And then a little bit about what we have. Oraworld is a magazine. I think everyone should read this. It makes the user community stronger. This is made by the European user groups, and it has no ties to Oracle. So people say things more straight in it. It's not marketing, it is for real. And here's a few of the things that's been in here before. As you can see, it's a lot of different things. It's from very technical to overviews to trend spotting. So everyone can find something in it that you like. So just search for it. It's online. You download it or you subscribe to getting it shipped to you. A few different ways like that. And we also get strength by numbers. So if you do download this and read it, it helps the user community both in how strong we are towards Oracle and how strong we are towards sponsors. So today, on what we're going to use today, and we're not really going to use it, but I'll get to that. It's the Oracle Cloud. It is Apex version 20.2. The database is 19.5, and it's on autonomous transaction processing. Just because it's by far the easiest way to get things up and going and get my hands into the cloud and get used to see what Oracle has there. But as I said, we're not gonna use it per se. And the reason is that I've captured the pictures that we need to show it, and it helps me from having to switch back and forth. But this is one thing I would like to get feedback on. I think this works sometimes better in Apex to show it, because I can highlight where it is you want to focus your eyes, what it is you want to click on a sometimes a busy screen. But it's not live, and if it would feel more interesting, more inspiring, if it rather was a live web interface that I showed it in and clicked on it, I would like to know that, because it helps me making better presentations. So I'm going to talk about 3 alternatives, and that is setting up the stage for what we're going to walk through here today. In alternative 1, on using the REST data sources, and this is what used to be called web source modules. We're only going to use that. We're going to limit the structure, and we're only going to be able to show what's now real-time access to a REST service. So let's stop there and let's talk a little bit about REST data sources. it is a declarative way to access a REST service. We can then use it as if it was a table to some extent. And that's what this is. You declare it in Apex, but as we'll see, you don't have to build things in Apex because of it. It's just where you define things, and with some of these things, you don't build an Apex application on top of it. You can build any kind of application on top of it. But for alternative 1, we're gonna stick with Apex because that's what alternative 1 leads us to. Alternative 2 takes alternative 1, which just was a definition of a web service. We could call it real time when we needed to, and we take it to the next level, and this is syncing data from it to a local table. It limits the structure we can use in the JSON document that is returned from it, but now we get into a table. We're no longer tied to only building an Apex application on top of it. We can build anything that is SQL or some such. It could be straight SQL from outside from a Java or .NET application or whatever language you fancy. And then in the last alternative we're going to look at is going to be the no limits alternative. It's where we have custom PL SQL. We can reuse the defined data source. We don't have to hard code our JSON or our REST call, and it's not tied to implementing with Apex applications. It works just as well in Apex, so it doesn't limit it to not be Apex. But if you want to build something else, then the Apex interface is just where you define your data source. So in our first version, we're going to use USGS. It's United States Geological Services, and they have a lot of open data that works very well. And for this, they have a service that shows earthquakes that has occurred in the last hour. That's the service we're going to use. We're going to create a declarative REST data source for it, and we're going to show that we have access to it by setting up an interactive grid in Apex to display data as if it was from a local table. Let's first take a look at the JSON document we're going to look at. And we're going to return to look at this quite a few times today. I don't know how many times. Say 6. So this is how JSON looks, right? This is a document. We have the brackets around everything in the outer part. And then in it, we get to some data. The type is a scalar value of a string. Metadata, which is an object containing a bunch of key value pairs. Features is coming next. It makes it a little bit more interesting. Here's an array, so we're going to get many features, and the feature is an earthquake. And we get a lot of data, where it occurred and how strong it was, and a bunch of technical data about it. We have an ID, so we can identify it, and then we have what's called bbox. I have no idea what it is, but the data is somewhat similar to what are the coordinates that we find in the geometry up in the feature, which is an array of 3 numerical values that tells us where it was located. Here we get 5. And 3 of them are similar to the coordinates. I don't know what the other 2 are, and I also don't know what it's used for. It's just technical data that happens to come with it, and maybe someone knows what it is, but I don't. So let's take a look at this. In Apex, we're going to create this data source in the shared components area. We give it a name and we drop in the URL endpoint for it. Next, we'll just click through, click next until we get to the last page. That's where it becomes interesting. The rest is just standard stuff when we're gonna play with this. So on the last page we get to is the data and the data profile. Data shows the columns that Oracle has automatically broken this up into. And yeah, so we see the columns and what it's going to be for the first few rows here. In this case, for all rows, because there's not that many rows. But if you have thousands, they're just going to show you like 25 or whatever it is. And here's the data profile for the same thing. Here, instead of data, here we show the table layout. That we have an ID, we have a data type for it, a length for it, and so forth. And the selector is the JSON path to the data in the document. And with that, once we've pressed finish on that last page, we're done. We have a declarative setup. And now we can go create an Oracle application and set up an interactive grid and just see that it works. So let's do that. So here we're in an application, we're creating an interactive grid. We select the REST data source as our source for the data. The normal thing is that it's local database, and then you select tables and do the normal stuff that you're used to. So this is just another variant of them. We select the name of it from the drop down, and in this case all columns are selected to show up in the interactive grid. And with that we run it, and it shows data, and there's nothing more to it. So we have completely built this from pure declarative setup. We just point it to a REST service and we use it, and there's no code, there's really nothing. The only thing we fill in is really the endpoint of the REST service. I think this is fantastic. The fact that you can do that and you can get it out in a grid, and you don't have to do anything for it, is really, really nice. When I saw this from the beginning, I was very surprised how simple it was to use. So now, next thing we're going to look at is what we talked about from the beginning, what I talked about from the beginning as alternative 2. Here we're going to save data from the REST service into a local table. It allows us to cache data, and in that case we choose to replace all the data that we have, or we update it doing a merge, which means that only new rows are updated, old rows are kept, so that we start building up a history or store every time we see, every time we call this. And for some services, I suppose that may be a nice thing. A service that returns the same kind of row every time for a long time is not what you would like to use a pen for, I presume. But you're going to get multiple copies of the same data then. So when we're going to do a merge, we need to have a way to have the data, to match up data we have in the table with data we just got from the REST service. How we're going to identify which rows are the same row and which ones are not. The way we're going to do that is to use the ID column that we saw before. And JSON path is relative to the row selector. And let's talk about the row selector. I'm not sure. Do I have a place I show it? No, I do not. When you set up a function like this, Oracle guesses on a row selector for you. And here it has guessed on the first array you have in your REST service. That's what it always does. The first array is what it picks because it wants to find something that is like a table that has multiple rows and shows things for you that way. And it's the features array. So that is what the row selector is, and the JSON path is relative to that and doesn't start from the beginning. So let's take a look at it. Here's our JSON document again, or parts of it at least, and we have the ID column, which is our param key that we want to select. So we go into the data profile again in the shell components and the REST data sources. All we need to do is to go into that column, edit on it, and change it to be a primary key, and then Oracle is going to use it for us when we do the merge. So let's talk about it. So now we've set that up. What we now want to do is to schedule a job to synchronize the data. Because that's essentially what we want to do, right? When we synchronize data, we also want Oracle to take care of it for us, to do it regular enough to make to make the updates. We don't want to have to do it ourselves. We don't want to write a little bit of code for this and schedule it ourselves. We want Oracle to do it all by itself, and so that the table keeps growing with new data, and we just can show it to whoever wants to see it. So let's see how we do this. On the REST data source, on the right hand side, there's this set of things. Like for anything, you can choose by some things that Oracle has put there that is special or frequently used or something like that. And in this case, it is manage synchronization. That is the stuff we want to take a look into. And when we get into that, Oracle tells us, or the Apex interface tells us that we have not yet configured synchronization for this table. And we can then pick which schema we want it to be located in. In many cases, you only have one schema because you haven't declared more of them than what your workspace uses. But if you do, you get the choice to select which one should hold it. And you could also have an existing table, but in this case, we're going to create a new one, just called USGS sync. And when we go next on that, Oracle informs us that this table does not yet exist. And we get the choice to create it. So let's do that. With the table created, we choose how we want to do our synchronization. As I said, we're going to use merge here. So we select that, and we select the range by the synchronization schedule box. We could just enter text in it for what the synchronization schedule should be, but it's a little bit easier to just click and choose. So we get this little dialog. In this case, I've chosen to have it synchronized every 15th minute. And from that, we're ready and you click save and run, which saves the information, of course, and then it runs it, and there will be a log here that you can look at if things worked out the way it should. It typically does if you let Oracle create the table, and if you create the table yourself, of course, there may be some issues. It's interesting that the tool in that case helps you fix the table. You get DDL for how to adjust it for it, and that is maybe more helpful than when you've messed up your own table. Then you can just fix it, I guess. But if the service changes over time and it has more data in it, and maybe it has lost a few columns that was there from the beginning, the synchronization keeps working, and you get help with figuring out how to adjust the table to be able to add the new data that has started showing up. And this is how the log looks when we've done the save and run. So it ran in this case. Sorry. In this case, there was 8 rows. And it had a size of 6 kilobytes, and we made one request and so forth. So there's some information there that you can click on the details to see a little bit more. It's not all that much more. It's kind of the same information again. Now with that, when that save and run worked, from then on the data is syncing. So I set it up to be every 15th minute, so it is. And when it does the sync, if the ID already exists in the table, it is merged and updated. If it's a new ID, adds a row to the table. The web service only shows an hour. That's what it's for. Our table keeps a history, so that after 1 hour you start getting more data into it from the next hour, and the old rows are just kept in the table. It's by choice. That's what we chose. We chose merge, so we get it to stay in the table, so we can see data over a longer period of time. So what we're going to do now is that we're heading back into the Apex application. Now this is optional, right? Because it's now in a table, and we could write any code. Could you do PL SQL? Could you do Java in the database? It could be Java outside the database. Could be anything that can run SQL against the database. But let's take a look at what Apex can do, because this is kind of neat how easy it is to just change it from a real-time access and only see what's real-time to seeing the data where we keep the history. It has this use synchronization table. It's a toggle. You just click on it, and that is changed to be on, and that's it. With that one click, this table is now showing you the data that you are saving in the table that shows the history. So let's talk a little bit about what it is we've done. This is still 100% declarative. It is scheduled updates on time intervals. It gets synchronized on those intervals. And the use is identical to how we used the real-time REST service. You just click a switch, and instead we're using our local table. And we're still at the point where it pretty much is just to point at an endpoint, and you get it all more or less for free. It really cannot be much easier to get data from a REST service where you even get history that service doesn't return to you. And we've not written a single line of code. Not sure how many frameworks can do this. So let's talk a little bit about what we still cannot get with this. For what I've seen, for what a lot of people want out of REST service, this is enough. This is what they want. But there are things that you may want to do that this doesn't do. For example, you could want to take from a REST service and break the data up and store in multiple tables. You could, while you're processing the REST service or the JSON document it returned, you may want to, based on what you see, decide what to do. And for that, you of course need some kind of logic. You could add a row to one table if it's a new ID, and you could want to add a row to another table if the ID is already known. What would an example of that be? It would be that you want to keep track of where someone is. So say that you get a return on what team someone is on, and if you've seen a player on the team, you already have it, but you want to say that he was part of that team today too. That kind of thing, which is where you just timestamp. It's like an observability framework, right? Where you observe that something is occurring or apparent. And it also allows you to process complex structures in different ways. It could be how you save data, but it could also be what you do with the data. So let's take a look at our JSON document and just talk a little bit about that. Even such a simple document has a fairly complex structure that doesn't lend itself to just be saved, all of it, into a single table. First we have type and the metadata, and in theory the metadata could be, you could remove that and not have an object, and you could have generated and count and all the other things out on the same level as type, and it could go into a single table. You may not want that, but it could be done. But then we get to features. It's an array. Since it's an array, it's a one-to-many relationship to the data that we just talked about, the type and the metadata. So you would need another table for that. That's how relational tables work, right? And then in the feature you have properties and you have geometry. You could very well want to have those into two different tables. They represent different kinds of data, and you may want to have those two have foreign keys up to the feature, which is what the array holds many of. Then of course we have the ID. It's not much to talk about that. And then on the bottom we have the array, what's called B box, that has 5 numerical values. It would also have to be a separate table since it's an array, or you could have column 1, 2, 3, 4, and 5. If you wanted to do it that way, of course you get a problem the day someone drops in a 6th numerical value into that array. And this document is a fairly simple REST service. The data it shows, in many cases you'll see much more complex documents. So then now we're going to talk about the JSON object. It's an API that Oracle gives us. This is the PL/SQL version of the JSON object. When you search for JSON object, sometimes you find the SQL variants of what you can do in SQL with it. This is not that. They can be used together, but this is stuff you use in the PL SQL language. So element T is the top level. Well, let me back up one step. This is implemented as object. It's not PL SQL packages, it is objects, and having worked with it for a little bit, it is the right choice, and it makes for a very nice API. So whether you like objects in the database or not, I'm not sure I would build an application with it necessarily, but building an API with it makes for very nice features. So element T is a top level class, or whatever you would like to call it. Object, array, and scalar are subclasses of it. And JSON key list is just an array. It is not related to the other ones. And we're gonna take a look at each of these a little bit to show how this works. But before we do that, we need to simplify the code a bit to not on every page repeat calling the data source and getting a JSON document back. And also to show how you would how did you use the declarative REST data source in a way where you from PL SQL can reuse what you have declared and call it the same way as Apex would call it. It's pretty simple. It's not really documented, but it's just a few lookups to do to find it in the Apex repository. So here's a select. We select the column. Let's see. Excuse me. We select the column URL endpoint. It is the endpoint like that we entered before, and we select it by knowing which application is it created in and what have we called the module. Then we make a call to the Apex Web Service package, make a REST request. We drop the endpoint that we selected from the repository in there and use a method of get. What we get back from Apex Web Service, though, is a CLOB. We want to work with a JSON object. We know that this is a JSON object, so we convert it by initializing a JSON object with the CLOB. All of that is moved into a little function that I'm calling in the beginning of all code we're going to see from here on. So this call to make the request can be much more complex. We can have an authentication key, we can have URL parameters, we can have other parameters, and sometimes you even need to set some headers. Especially in some of the REST APIs that's out there, the public ones, they use headers for authentication. Not when you need to properly log in, but when you just need, you've got an approval to use it and you just have an API key. That's typically in a header. So let's take a look here. So if we begin with just printing JSON, and with printing, of course, I mean showing. That's the common phrase. So we declare a variable that's of type JSON object T. We then call the getJSON data. That's where I put this function that made the call with the stuff we just looked at. Back comes a JSON object. And in this case, we're just printing it. And here we see one of the effects of using objects instead of doing some JSON object dot get string or something. It is the variable dot toString, kind of how you would see things in Java code and so forth. And it prints it. It doesn't print it looking the same way as it does in our JSON document, because this is the data that it is representative. It is not physically identical. It doesn't have the same amount of spaces and so forth. This is it's been read and it's been parsed, so the same exact information, but without all the spaces and so forth. So now the next step is to build on that and show how we can extract key names. We're going to look at taking the keys on the base level, and the keys is a name of a portion of the document. We're going to show which ones it is in a second here. So it allows us to extract a portion of the document, large or small portion, but some form of portion that has a name, which is what all things in JSON has. And they can also be used to introspect things in the document. If you don't know the names, you can get the names out this way, and then you can ask what kind of stuff is behind those names. So if we look at the document again, on the very base level in the object we've gotten, there really are just 4 names. It is type, it's metadata, features, and bbox. In those, there's nothing on the same level. Everything else is in structures inside those one way or another. So the first one, type, is a scalar. It's just a value, it's a string. And then you have metadata, which is a JSON object. Features is a JSON array. And bbox is a JSON array. The features array has 2 or 3, I guess, JSON objects in it. So every item you can bring out the type, which is a scalar, and then properties and geometry, which are JSON objects. So, but then you have to step down into the document to find those things. So these 4 are the only ones we're going to get now. So with a little bit of a look on this, we're back to we're declaring a JSON object, which is our whole document. And then we declare the JSON key list, which I said before, it's just an array. So when we get the data back, based on the data, we call the function getKeys, and we put it into the collection. And we then we step through it the normal way. We print each one out, and we get these 4 shown up. So this is how we know what named keys are on a certain level in a JSON document. Over to looking at an array. We want to extract the array part of a JSON document. We want to address each row in the array, and we want to print items in the array, which are essentially rows. It's not just a value, it's a set of key value pairs. So back to our document. Here we have the features array, and what the text is a little bit bigger. That's what stuff we're gonna get back, and we're gonna get back each feature that's in the features array, and we're gonna print that out just to see how we pull it apart. So here we have it. We, based on the JSON we get back, we call get array on a name, in this case features, so we get that array from the document, and with that we can step through it. Since it's an object, get size is how we get it. It's not count that we used to with a normal, or with a collection. And we print it with a call to get the row, or whatever we want to call it, the item from the array, and we call toString on it to print the JSON portion. And below here we see that 2 of those has been printed with all the things that's in it, even the arrays that was in the array and so forth. But I want to stay here a little bit and talk about one thing that's interesting. A normal collection in PL/SQL is 1-based, meaning you start with 1 and you count upward. So the very first element in such an array is on an index of 1. That's not the case here. This is 0-based arrays. So we need to do a for I in 0 to get size, returns the number of elements, but since we start on 0, it's going to be 1 less. Is the one we're going to stop with. And in the DBMS output, it's a dot notation similar to what we did before. We have our array, from that we get 1 row, and from that row we call toString. That's how you chain calls like that in an object notation. And from this, we're gonna go in deeper into the array, and we want to pull out a scalar value, a single value, a string, or some such from it. So we're gonna navigate down through the JSON structure. So we're going to go from the array. From there we're going to have a JSON element. I'm going to talk a little bit about why it becomes an element there in a minute when we look at the code. From there we're going to look at an object, and in the object we're going to pull out a scalar value. So here's the code. We've seen it before a few times by now. The text I made bigger is what will be pulled out by the code. So we have the features array. From that we're going to get into the properties object on each row or each entry in that array, and in there we're going to pull out the title so that we can print this text. So now, very much is the same. It really is just in the loop that we do things different. We go into the array, we get one entry like we did before when we printed it, and after that we did toString. But in this case we're gonna go down into the properties area, and we're gonna get out a string from the properties area that is title. And then we see below that we printed a few of them. But there's more to it here. If you've written object-oriented code, you'll recognize this, or at least part of this. The lines in the put line, the first line, and then you have dot on the next two. So it is chaining them. It operates on the returns of the other things, right? So, but let's look at the first one. It says treat, and we're not used to doing that. But this is making an object be treated as another kind of object. The get returns an element as the highest level. It's an abstract version of this, and it could be one of three things. In this case, we know what it is, and we want to handle it as if it was an object. And since the subclass is of element, you can just say, I want to handle this as that. So that's essentially the object version of a normal cast like we do in PL/SQL. And then the dot notation is object-oriented way of navigating objects. So then we have a JSON object, and JSON object can call a get object on something that's in that first object. We pull out properties, and from properties we can pull out a scalar value that's in a property. But let's look at it in a different way, at least for those that find that way of writing the code a little bit confusing. We declare a few more variables. One that's going to hold a feature, one's going to hold a property that's in a feature, and one's going to hold the title that we pull out from a property. The rest is the same, except that what's in the loop changes. So now, instead, we run this statement one at a time instead of having them brought together. So we call the treat function to get one of the features, and we get that into JSON feature. So now we have a JSON object that contains a feature. In that is properties or a property. So we bring that out by getting the object properties from it. And now we have a property, and we can operate on that and get the string for title. And then we can print it. Which way one prefers is just personal choice, I guess. There are benefits and so forth with different things, but if you're going to pull out a lot of things from a property, you probably want to do it this way, and then call get string on all, get string or get number, whatever, on all the different things that are in a property. So now we're reaching towards the end of this, where we put it together, and we want to pull out some data, and we want to put it in a table to show that the custom PL/SQL does it the full way. At this point, we of course understand that we could do that, but so let's take a look at the data that will be pulled out, and it's in properties, one numeric value for mag, and the place where it occurred. And we do it for ID, so we're going to save the ID too. So we create a table with 3 columns, so we can store these 3 things. Now let's look at the code. We have 3 new variables: ID, title, and time. It's funny. It works the same way. It's not the columns I just said we were going to pull out, but that's fine. I made a mistake when I rewrote this, apparently. So then we do the same thing. We get into the loop, and after we get a feature pulled out from the JSON document, we call getString to get the ID. So our primary key is pulled off. Then we need to go into the property. So we extract the property into the JSON property variable, from which we can do getString on title and time. And then we just do an insert, like we always do, into a table and name the values. And for brevity, I didn't name the columns. And just to show that it actually works, here's the output. So, let's talk a little bit about what more can you do with this API, because we've kind of just scratched the surface of what can be done. It allows you to modify the complete structure of the JSON document. You can change values in it, you can add values to it, you could even rename keys in it to have a new name. You can introspect things, so you can ask, is feature an object or is feature an array? You could ask if a certain key is part of the object, and so forth. And while I start talking this, I noticed that there is no questions or comments really on this. So if you have something you want me to talk about, please enter something. If not, we'll wrap up when we get in a second here to the end. So in summary, there are lots of options for declarative access. You can most of the time use that, and that's all you need. If you want to get more advanced, there's a very nice API, very well written. I've yet to find something that I wish they would have put into it. I'm sure I'm going to find it one day. And with how well and how nice this works, there's no reason not to integrate with REST services from the database. Complete structure possible. I kind of talked about that recently, that you can, with this API, we can change the structure of the JSON document. We can remove things. We can move a certain object around in it, drop it deeper into an array or whatever. If you really want to go that crazy in managing a JSON document, and I think it finds it very very natural to be used in the hands of PL/SQL developers. This feels very natural to write in a PL/SQL code. It's not one of those that feels like, yeah, it works, but kind of feels like you're writing a different language. So I think everyone should try this. So that is it. We're to the end. See, Ola's writing something here. When synchronizing data, what happens with version control of data? Not really sure I understand the question. there. Is it about audit columns? To know who updated something, or is it to keep track of all the different changes that has occurred so that we can see the history of a row? If someone saves data before, this table is not meant to be updated by someone else. So if you have other people updating the same table, I'm sure there could in theory be problems and overwrites. This is not meant to be both saved from the REST service and from people. So I think you want to keep those things apart. And if you want to synchronize from one place and then you want people to update it also, I think you want to do some special work there where you may have the local changes in a different table so that you can bring them together and keep track of who has what. Otherwise there's of course a risk of being overwritten. So I wouldn't use that to save my own data too, because then it's going to be synchronized away if that row is changed over by the REST service. I haven't tried this, but I'm pretty sure that is what would happen. But let's take that one step further. If we don't talk about it as being synchronized locally, if we talk about it just as a REST service, we get data, we put it into an interactive grid. If it's an updatable REST service where it has features to put, or not just to get data, then interactive grid works with that, and without writing code you can get it to declaratively update data out on a place where someone in-house or publicly has a service that allows you to update data. Could this be done only from the database without Apex? Well, I view Apex as part of the database these days. It can be done without writing an Apex application. Can it be done without Apex? Well, it can be done without Apex in such a way where you don't go into the web interface of Apex, and you could write a script that sets these things up and creates the module. But is it Apex then, or is it not Apex? I don't know. You don't have to have. Would you have to have Apex installed for that? I'm not sure, because these packages, the Apex installation is really bringing in the interface. I imagine that you would want to have Apex installed to do this, but I would have to try to know for sure if it's needed, or if this is packages that you would have access to anyway, because the database can do network work without Apex, of course. So I'm not sure. But you can definitely use it without it. I would today view that you want to have Apex for the things that are around it. with things like this and other things like that, where you can set things up and get things working, even if you don't want to build Apex applications. So you could lock down the builder and not even allow people to create things if that's what you want. But I think you want to have this. It's essentially ORs that we're talking about at some point, right? ORs is becoming a very important piece, and ORs can be run without having it for Apex. But if you want to do REST services, if you want to run SQL developer on the web, and if you want to do a lot of these things that are already here or are coming, it's a critical piece of your database. Okay, I think we're at the end of the comments and questions. Would like to thank everyone for coming. This was a subject that interested many people, apparently. We would like feedback both on how well it went, but also on what makes what kind of things do you want to see? Are these the things that are on the side of Apex very interesting, or is something into the meat interesting? Is there a certain new feature that you would want us to find someone that wants to talk about, and so forth? So if there's something special you would want to hear, let us know, and we'll see if we can figure out how to deliver that. Magnus Pelén asks if I prefer PL/SQL or SQL functions with JSON table to parse JSON. My general feeling is that I want to do things as close to where I get hold of it as possible. So if I get the JSON in by calling service this way, I would stay in PL/SQL and take care of it if it wasn't clear why I would throw it in to do it in SQL. If I pulled it off a table with SQL, I would probably stay with SQL to do things because to avoid context switching. I have not compared this. I don't think there's major performance difference with it. From what I've seen with the little I've played with it, but what I've played with and to the volume I played with, I've not seen it being a problem. I would say that JSON in the Oracle database is amazingly fast. Some things are so fast that you would think it would be possible. Like you can run SQL over REST, and you really see no appreciable difference. You can run it. There's a JDBC driver that does it. That is using REST rather than, I guess, JDBC. And the performance is about the same, at least for what I've seen and what I've heard, what I've read. So that's my take, I guess, from what I know now. Let's see, Ulf has said something. Yeah, Ulf is kind of saying the same as I said, that even if you don't want to build Apex things, it gives a lot of development features to give you a nice tool set to do things that are much more modern than just pure processing SQL in a database. Like this, where you can bring in data, it can be completely declarative, and you don't ever need to really deal with network transport and all of these things that is going on with making a REST call. And there are a bunch of other things. A few years ago, I presented around using it to do call to BankID, the Swedish service to prove who you are. And today that would hook into this in one form or another. So there's a lot of very nice things that you can do without building Apex applications if you don't want to do that. So I think you would want to have that there anyway. For the features it brings. And if you look at Oracke, it started as a piece of Apex, but it has been branched out, and today it provides a lot of features that is not really Apex anymore. Some of them are not it's kind of used by Apex, but not really. So it is more becoming a piece of infrastructure that you would want for your database. Okay. I'd like to thank everyone for tuning in. I think this was a fun presentation to hold, and I think playing with this JSON stuff is really funny or fun. It's neat, has a neat API, and it's easy to get a lot of value out of the code with just a few lines of code. So with that, thank you and see you next time.